result of immunoglobulin gene fragment rearrangements. So we can say at this very moment, each of us has in his own body more than 1 million receptors on lymphocytes, distinct receptors on lymphocytes. And lymphocytes can also evolve into memory cells on the basis of vaccination. Now, again in this context, to show the kinetics of innate and adaptive immune responses in bacteria challenged mice, this is a compendium of several hundreds of experiments. You see innate immunity appears rapidly, 5 to 7 days, whereas adaptive immunity takes longer to appear, and it lasts also for a longer period. So this is general in mind for us for this evening. Now I'm going to the part 2, and deciphering the antimicrobial response of insects. You see here we have worked on grasshoppers, and that was the traditional laboratory in Strasbourg, which I joined for my PhD. And grasshoppers were of importance in France at that time, because France has, as I expressed myself, responsibilities in northern Africa, and grasshoppers were a big plague in these times. We then turned to Phomia terranova, which is shown here, which is sort of blowfly, and finally the recent years, the last 20 years, we were essentially on Drosophila melanogaster, the fruit fly. Now let me remind you that insects can be attacked by fungi, bacteria, viruses, protozoa. They account for 80%, 80% of all living species on Earth nowadays. And they are particularly resistant to infections, which was known when I started my PhD work. Now, the question which we asked with my supervisor, Professor Pierre Joly, who disappeared 20 years ago, unfortunately, the question which we asked, what can we learn from the defense reactions of this important group? We sort of believed that it would be very different from what happens in mammals. There was no indication that it was adaptive immunity, so we supposed we would be in the presence of a pristine innate immunity. So this is an example of an experiment where you prick a fly with a needle which has been dipped into bacterial or fungal cultures, and you take off the blood after given time intervals, and you see that you have assay here, very simple growth inhibition assay. You have the appearance of a strong antimicrobial, antibacterial experiment activity. There's nothing in the controls. So the questions which we asked were threefold. Number one, what is the identity of the effector molecules? There had been a few years ago a work in Stockholm by Hans Bohmann, who had isolated from butterflies an antimicrobial peptide. So we assumed nothing was known in the fly, but we assumed we might be in the presence of peptides. And the second question we wanted to address then would be, once we had identified the effector molecules, how is the expression of the genes encoding those putative polypeptides, how is that controlled? And the third question we intended to ask was, which sort of receptors tell the insect that an infection is going on, or can it potentially discriminate between various infecting agents? Now, let me take you quickly through the responses to those three questions. Number one, we identified over several years, we are a relatively large laboratory with competences both in chemistry, biochemistry, molecular biology, genetics, and so on. So over several years we found that the site of response to the infection is the fat body in the fly, which is sort of an equivalent of the mammalian liver. We found several families of molecules induced. They're all small size cationic peptides which attack the membranes of the microbes and disrupt the membranes. To be short on this, as I'll take the time to go into more detail. Let me just point out that dipteroceans are antibacterial, and they were the first molecules which we identified in the laboratory in the late 80s. Drosomycins are antifungal, and they play